Okay, so grade 12s, we are looking at the recursion problem set. This question here is given a non-negative integer n, return the sum of its digits recursively. Note that mod by 10 yields the rightmost digit, so 126 mod 10 is 6. So we get the 6 from there, while divide by 10 removes the rightmost digit. So 126 divided by 10 is 12. You guys following? All right, so really what we want to do is add the digits up. This is just a hint. So this is telling you how to do it, but which you should already know. So you're lucky you got a hint there. But 126, so 1 plus 2 is 3, 3 plus 6 is 9, right? Now, how are we going to break down this problem recursively? And it's always good to think, how do I think recursively about summing digits? So you get your piece of paper out, right? And you think, how do I break down this problem recursively? So, is that a hand up? Maybe? Maybe I'll call on you then? All right, go ahead, Baz.
This is some digits, yeah?
Some digits, yeah.
So, if the number divided by 10 is equal, like if it's 416, then the number divided by, then the number divided by 10, I think that part would have to repeat instead of, because that would just take away the rightmost value. But
Yep.
you want one digit at a time. So
Right.
You should probably like repeat that.
So, yeah, I mean, like, so you remember when we did factorial, right?
Yeah.
So what I'm asking for is, like, don't give me necessarily the math behind it, but when we did 5 factorial, we said 5 factorial. How do we compute 5 factorial recursively? We said 5 factorial is equal to 5 times 4 factorial. And then we said 4 factorial is equal to 4 times 3 factorial. And we kept going all the way until we got down to our base case, right? So how do we do this with some digits?
Would it be 4 plus 179, or like the sum of the previous digits?
Exactly. So you would say, take the rightmost digit out. So you would say 4 plus the sum of digits of the rest of it, 1, 7, 8, 9, right? Then you'd say, okay, so you take the 4 and you'd say, okay, sum these digits and add it to 4. Then you'd say, okay, let's take the 9 off and say plus the sum digits of 1, 7, 8. Right? Plus the 4, right? So plus this, right? So this part, just this part is down here. So I don't have to do that because that's this part. And then I would go, okay, to sum the digits, so this part right here would be 8 plus sum digits of 17. And then this right here would be 7 plus sum digits of 1. Now, this right here, what's the sum digits of 1? 1. So when did we stop? So then we go, that's 1. So then we can go 1 plus 7, that's 8. Then we go 8 plus 8, that's 16. Then we go 16 plus 9, which is 27. No, 25, isn't it? And then we go 25 plus 4, which is 29, which hopefully is the sum of all these digits. 1 plus 7 is 8, 8 plus 8 is 16, 16 plus 9 is 25, and then 25 plus 4 is 29. So you can see that how it works, how we're building it up recursively. And that's where you get your recursive call and your base case from. How can I think about this recursively? Does that make sense? All right, so let's go here and program that. Once you've done that on a piece of paper, you can then think of how to do it. So now it makes it a lot easier because you know what your base case is. Your base case could be when you are less than 10, right? So if n is less than 10, again, assuming a positive number because it says given a non-negative int. So if your base case is less than 10, what should I return? N, right? This means it's one digit. So if it's one digit, like, what's the sum of the digits of 7? It's just 7. So return n. Else if, okay, are there any more base cases that we need to think about?
Oh,
Yep.
so if you reach the end number, it would basically be zero, because any single digit divided by 10 is like almost guaranteed to be zero. So that's how you know when to stop, right?
Any number.
Or wait, no.
Well, you could go down one more step. But we're just saying, okay, once we're down to one digit, you could go down to being 0, return 0, right? If n, so you could do this. If n equals 0, return 0. So you could do that too, because eventually the one digit number, like 7 divided by 10, integer division would give you 0, right? So you could stop there too. Or you could just stop one step before. So what this will do is stop one step before that. And return n. So it will work both ways. Now what we can do is then say, okay, let's get the rightmost digit. So int 1's digit equals, and we want to get the rightmost digit, so they tell you how to do it here. 126 divided by 10. So n is 126, for example. Mod 10. And that will give you the 6, right? If the n was 126, this would give you the 6. Then we go int, and I always like to keep that example fresh in our head. And we can call this the rest of the number remainder, let's say. Remainder is equal to n divided by 10. So then in the case of 126 mod 10 would give us 6, but n would still be 126 until we divide it by 10, which then gets rid of the 6 integer division. So instead of getting 12.6 because it's integer division, you'll just get 12. Remember, it floors that, gets that decimal off there. Then, because this is, we have to return something, right? So we return. Now we think about how we did this recursively. We did this recursively, yep, by doing the rightmost digit plus the sum digits of the rest of it. So what's that statement there? Sum digits of remainder. Okay, so that's the solution there. All right, so we can go up into our main method and test it out. Do you guys want me to? Do you want to see this in the visualizer? Yeah. So I can take this and let's get a Java visualizer going. Sorry, my computer's crashing on me at the worst time. So in the Java visualizer, everything's very slow today. So obviously I don't put that in the main method. I'm pasting my method here. And here I should call it. So let's go system.out.println sum digits of, say, 15. Actually, let's go 1, 2, 3, 4, 5, which is 15. The sum of 1 plus 2 plus 3 plus 4 plus 5 is 15. So let's visualize that. If we go to the last, let's see, we do get 15. Let's go back to the first. So I'll go forward. All right, so now we're calling sum digits with 1, 2, 3, 4, 5. It's added to the top of that stack of methods that are being called. Right? Now, is that less than one digit? Sorry, is that one digit? No. So it goes to the else. It says 1's digit is 5, which is working. Good. And the remainder is 1, 2, 3, 4. What we then do is we say, let's call the method again, but we're going to add this to this, just like we did on our algorithm on our piece of paper. So we're going to add 5 to the sum of the digits of this. But now we need to find the sum of the digits of this. Guys, whisper. So then we do that process again. We take the 4 off. We get the remainder. We say, let's add this to the sum of the digits of this. Once we have that, then we know the answer to the sum of the digits of this, so we can bubble back. But we do then need to find the sum of the digits of 1, 2, 3. So we repeat that process recursively, call the method again. From within the method, adds to the top of the stack. We do that process again. Then we say, oh, we need to know the sum of the digits of 12. So now we go into 12. It's not 1 digit, so we take the 1 off and we say the remainder is 1. We need to find the sum of the digits of 1. This time we hit our base case because 1 is less than 10, n is less than 10. So the sum of the digits is just 1. If n was 7, for example, it would be 7 is less than 10, return 7, which is the sum of the digits of 7. So we return 1, 1 gets returned over here, and then remember this line is we add the 1's digit plus the sum of the digits of that. So 1 plus 1, 1 plus 2, which gives us 3. That pops off. Once it returns, it pops off the top of the stack. Return value is 6. Return value is 10. Return value is 15. And then it will print the 15. Make sense? Questions? Pretty cool how recursion works, right? Pretty cool. All right, should we do the next one? Any questions about that one? All right, the next one says, given an array of ints, compute recursively if the array contains a 6. We'll use the convention of considering only the part of the array that begins at the given index. In this way, a recursive call can pass index plus 1 to move down the array. The initial call will pass in index as 0. So this idea is used often, especially when dealing with arrays. So for example, in this array, we want to see if there is a 6 in there. We know there's a 6. We see a 6. But how do we do this recursively? So first we check the first index. Is it a 6? No. Then we move on. Is it a 6? Yes. So then we return true. As soon as we find it, we can return true. So then you got to think, okay, how could I solve this problem recursively? So again, let's come up with an array. Let's say it's 1, 2, 3, 6, 5, 3. Okay, so we want to see if there's a 6. So how do we compute it recursively? So recursively, we kind of look at the first element. We say, is this a 6? No, right? So if it's not a 6, if it is a 6, what do we do? We return true. We know we found the 6 and we've answered the question. But if it's not a 6, then what we want to do is then say, let's shorten the array now. And again, look at that first element in the array. Is it a 6? No. So then we kind of repeat that process and say, let's look at that. Is it a 6? No. So let's repeat that. Is it a 6? Yes. Now once it's done, we can bubble back down the list. Now we can't really shorten arrays, so that's where the index is coming in. The index is going to move and tell us which element to look at. So that's why this takes in 2. So you can see I've got public static boolean, it's returning true or false. The name of the array is array 6. And we take in the array called ARR, and we say int index, which is telling us where to start looking. So now, what are our base cases? We might have more than one. So in one case, we could have an empty array. So what if the array is empty? So that means that ARR.length is 0. If the array.length is equal to 0, we return what? False. Because there cannot possibly be a 6 in an array that is an empty array. So this is taking into account an empty array. Now, next, let's check in the array at the given index. So if nums at index, sorry, not nums, ARR at the array at index is 6, right? What do we return? What does that mean? We found it, return true. Now this is another base case, right? So in recursion you can have more than one base case. So that's another base case. We found the element, return true. We don't have to keep looking. We just want to know if there's 1 6 in there. So once we find a 6, if there's more than 1 6, that's fine too, but this is just asking, did we find even just one? So then, next, is there another base case? What about if the array is not empty, but there's no 6 in it? Did we cover that?
If the index is equal, or if the index is greater than the array length, and it still has.
Exactly.
Because if it did find the 6, it would activate that. If that if state.
Exactly. So we can use the good bad. We can use like lazy evaluation here. So if we did find a 6, it would have done that. If we're getting to this point, it means we didn't find a 6. So all we need to do is check if the index is equal to array.length minus 1, which is the last element in the array, because remember that arrays start with an index of 0. So the last element in the array is array.length minus 1. So if index is equal to that, that means we stop. If we don't have this in here, we would get an array index out of bounds exception. So here we return false. We know we haven't found it because if we did find it, this one would have executed, we would have returned true, and we never would have gotten down here. And now, so those are all our base cases. We've taken care of all our base cases. Basically, our base case is, did we find it at the index or did we not find it at the index? This is just one special case of, is the array empty? I'll have to print it, so just give me a minute. So what we'll do here is, now what's the recursive case? The recursive case is when we call our method again. So we want to return, we do want to return something because it has to return true or false.
Just return because it's a Boolean statement in itself.
Yep,
So
exactly.
So you can just call the method with the index plus 1, right?
Exactly. So index plus 1. And that's it. That's the whole method there. We can run this through the Java visualizer. Okay, we can call array 6. Here we can call array 6. We should make a new array, so we can say new int, and then put some values in it. 1, 2, 4, 6, 3. Let's say, right? So this is a shortcut to, well, it's not really a shortcut, but we make the new array and then we just plop it into that method. Oh, right. And what I'm forgetting to do is also pass in the index. So what should the first index be? 0, right? If I want to check the entire array.
Oh yeah.
So I plop forward, I get my array over here. All right, we see that there's a 6 right there in index 3. So is it empty? No. Is the array at index 0 a 6? No. Am I at the end of the array? No. So then I call the method again, gets added to the top of the stack, but now index is 1. So I repeat the process for this. Is it a 6? Is it empty? So this one's going to be false all the time because we know the array is not empty. This one is false until we get here. And so we always go to the recursive case, which is just saying, okay, check basically the rest of the array. So check index 2. So we check index 2. It's still not empty. It's still not 6. We're still not at the end. So then let's check index 3. Notice that we cannot finish any of these. And notice that these arrows are showing you pass by reference, right? All of these methods are currently referring to the same array. So now, at index 3, we do get a true, because it is a 6. So now that can return, and once it returns, that can pop off the top of the stack. That means the previous one can return, because it's just going to return whatever the other one did. And that means the previous one can return. And in the end, we do get a true down here that prints out. You can edit this code to remove the 6 from here. And check, you should also check that that still works. If it doesn't find it, there's no index out of bounds exceptions. Everything's slow right now, but it should still work. Oh, it didn't like that it couldn't find the 6, is that right? Why did it take so long? Let's try that again. Oh, there we go. It just bugged out. Okay, so we've got the array there. Not a 6, not a 6, not a 6, not the end. But eventually we get to the end here at index 3. It says, okay, we're at the end, so therefore return false. And then it just returns false all the way back through. And we get the false out. So, make sense? Questions? Now, one thing I didn't talk about earlier, we can talk about abstraction. Do you guys know what abstraction means? Kind of hiding the details from the user. Right now, the user, generally speaking, when they call this array, they probably want to check the entire array, right? More often than not. So having them put in this extra index is a bit annoying. It's just like in math.abs. When I taught it to you, I just taught you like there was one math.abs, absolute value. If you give it a double, it returns double. If you give it an int, it returns an int. You remember that? But little did you know, later on when you study method overloading, you realized what? The details behind the scenes, which were that there's more than one ABS method overloading, right? So that's abstraction. Abstraction is hiding those details. It's like a need-to-know basis. Why make things complicated for the people who are going to use math.abs? Why name it something different so they have to learn all these different things? Just name it the same thing. They don't need to know that there's two methods back there. You've abstracted the concept from them. So here, you can abstract how this works from the user by simply making another method that calls this one. So, and you could actually use method overloading here too. So you could just say public, or you can call it something different altogether. They do this concept, in things like quick sort and merge sort. So we still want to make it Boolean. We'll go array 6. And the job of this method, the only job of this method, and you won't have to worry about this tomorrow. You won't have to do this tomorrow on the quiz. But the job of this method is just to take the array. Now notice that we can use method overloading because this one takes 2 parameters, this one just takes 1. And in here, all I'm going to do is say return. I'm going to call the other method, array6 arr comma 0. Right? So now I'm just by default putting the 0 in there. So now from the main method, right, you could just do something like this. Instead of going check the entire array starting from position 0, you could just say check the array, check the whole array like that. So you've abstracted the idea, the detail from the user. Does that make sense? Okay, so you've kind of like wrapped it. You've wrapped the recursive one into another one so that you don't have to the user doesn't have to put that 0 there every time they want to call it. And this is not recursion, right? The way that this method is not recursive. Even though it looks like it might be, why is this method not recursive? It looks like it is because it looks like it's calling the same method, but is it calling the same method? No, it's calling a different method. This one has 2 arguments, this one only has 1. So this one's actually jumping up here, using the rules of method overloading, calling this one. And this is the one that's recursive, because it's calling the same method with the same number of arguments. That make sense? Questions? Now, one thing I didn't show you earlier with some digits, I mean, it says it's a non-negative integer n. What should we do if we wanted to? Now, I'm not going to make you do this tomorrow, but if we wanted to, I mean, here you could just say, I'm assuming that it will only be called with positive numbers. But let's say the user did put a negative number in. So if n is less than 0, what should we do? So we can change this then to an else if. What if n is negative? Yep. Yeah, I guess you could decide how you want to do it. So you could say for negative numbers, let's still add all the digits and make it positive, or let's add all the digits and make them all negative, or let's add all the digits and make the first digit negative. There's a bunch of different ways to do it. Let's just say we didn't want to do it. Let's say we wanted to just return an error message. What do we do? Yeah, I can't just write system.out.println, hey, it's negative, right? Because, why can't I do that? It needs to return something. There's a return type here. So that's where you could go throw new runtime exception and then put a message in here and say negatives not allowed. And that will let it compile so that, but if the user does call it with a negative, then the program will crash for them. Right? Now, we haven't talked about try-catch, but that's where try-catch comes in, where the secondary programmer could put a try-catch around it and deal with that situation in the event that a negative was put in and an exception was thrown. Okay. Any questions about any of this recursion stuff? You guys ready for your quiz tomorrow? Okay, so there's the last one there, count 7. I won't take that one up. You guys want to try that one on your own?
Is it going to be a coding quiz or like a answer quiz?
Coding quiz. Easy problem and a hard problem.